Hello and welcome to Techie Hive. In the previous video, we talked about how Java program is portable across multiple platforms. Today, we'll discuss another top Java interview question and a question you can see on the screen. How does Java handle memory management and what role does the garbage collector GC play? What are minor GC, major GC, and full GC? Interviewer will ask this question to know that you have a good understanding of Java memory management. Unlike C and C++, in Java, memory management is done in different way. So let's go to the answer. Java uses automatic memory management, meaning the Java handles allocation and deallocation of objects so the developer does not have to manually fill the memory. The process to claim memory back assigned to the user-defined objects is called garbage collection. And here is the high-level diagram of Java memory management. So Java divides the memory into multiple sections. Here you can see the main section is the heap where all of the new objects are allocated. And then we have stack memory where we have all of the local variables, primitive types, and method frames, etc. In meta space, all of the classes and GC roots are stored, and other meta information about the JVM is stored. The user-defined objects are stored in heap memory, and heap memory is further divided into two sections: young generation and old generation. In young generation, there is hidden space, survivor space 0 and survivor space 1. So when a new object is created, it is placed in hidden space. And during the next minor GC, all of the live objects from hidden space are moved to either S0 or S1, depending which one is empty at that time. And object survives multiple minor GCs. There is a threshold for the survival of minor GCs, and I think in Java it's 15. So after 15 minor GC cycles, all of the live objects from S0 and S1 are moved to the old generation, and they are kept over there until next major GC happens. So in summary, young generation is cleaned up during minor GC. Old generation is cleaned up during major GC, and full GC cleans meta space, old space, and the young space. Let's see how minor GC, major GC, and full GC happens in the JVM. So in the case of minor GC cleans young generation, hidden space, and survival space. Happens when hidden space is full. So when hidden space is full, then you know uh, minor GC happens. It's very fast and happens frequently. Stop all application threads briefly. Stop the world, but usually for the short time. Use that young objects, moves surviving objects to the survivor space or to the old generation. So minor GC happens frequently and it's very fast. It stops the threads of the application for a short time, but it's very efficient. In the case of major GC, it cleans old generation space. Happens when old generation space is full or nearly full or survivor promotion fails. Let's say survivor, there is a threshold reached for surviving the object in survivor space, so they need to be moved to the old generation. But that promotion is failed. At the time, major GC will be triggered. We can trigger major GC using the system.gc explicit command, but it's not recommended. And also it's not guaranteed that it will trigger the major GC immediately because it depends on the on the JVM, whether it is ready to do major GC or not. It's much slower than minor GC, can cause noticeable pause time when a GC algorithm cleans long-lived objects, often more expensive and operations, complex and marking etc. So major GC is a bit expensive in comparison of the minor GC. So major GC happens very rarely. In full GC, it cleans both young generation, old generation, and multi-space. Often most expensive in GC event usually involve full rest of the world pause. A properly tuned JVM should rarely or never run full GC. If full GC are happening frequently minutes or seconds, that indicates a problem. There might be some memory leakage or some other problems in the application if full GC is happening, frequently. Next, let's see what garbage collection algorithm are used by JVM. So here is a list of garbage collector algorithm. So first one is the serial GC, and we can force JVM to call or to use serial GC using this option. And this is stop the world single threaded type. Simple GC using single threaded young and old gens collection, lowest overhead but highest post time because it's single threaded, so it takes more time to clean up the memory. So it's highest. It has a highest post time. Next one is parallel GC. So it was used prior to Java 9. So this is the GC with high throughput, multi-threaded. Because this is high throughput, so multi-threaded young and old generation GC focus on the maximizing throughput. Pause time can be long because it has high throughput, but still pause time could be long in that case. Next one is CMS concurrent and mark swap. So it is low pause time, mostly concurrent. Old generation collecting mostly concurrently, reduces pause time but uses more CPU. Deprecating after Java 11, sorry Java 9. So this has low pause time, but it has it use more CPU time. So it was deprecated in Java, after Java 9. G1 GC. So this is the default GC after in Java 9 or higher versions. And this is region based low pause GC. So is region based. It doesn't clean entire uh, old generation space or young generation space. It divides the all of the memory into regions and clean the regions by clean the memory region by region. So heap divided into regions collects young and old regions incrementally and predictably. Pause time default GC. So this is default GC for Java 9 and higher versions. Then we have the JED GC. You can just force JVM to use JED GC. This ultra low pause, fully concurrent. Pause time is very less. It's less than 1 millisecond. It scales to multi TB heaps designed for soft real time systems. Next, let's see the object references used by JVM to optimize the memory usage. And this is the list of the references: soft reference, weak reference, phantom reference, and real reference. So soft reference are collected when JVM is low on memory. So when JVM is running on low memory, then soft references are collected and they are generally used for caching the object. So for creating cache, soft references are used. Weak references, they only survive one GC cycle. Okay, they are collected in next GC cycle, and sometimes we need some very low surviving objects for listeners of metadata, and for them we can use the weak references. Phantom references, they are used for cleanup purpose. So when phantom like objects when object is finalized, then the reference is pushed to the reference queue, and when there is a reference queue, then we can do the cleanup for that object. The last one is real reference. So all of the objects created by user using a new operator, they are real reference, and they are reachable until they are collected by the garbage collection. So garbage collect them when there is no live reference exists for the object. So next, they are reachable until they are uh, collected by the garbage collector. Mostly they are business object, and GC does not collect them until they are unreachable. So if there is any live reference to the object, then these objects are not collected. So this is the quick summary of Java references, and these references we can use to optimize the JVM and to minimize the memory usage. Okay, that's all I wanted to cover in this video. Hope you like it. See you in next video.